In this video, we are going to see about the circular doubly linked list deletion. There is two cases. One is deleting the starting node, that is a beginning node, and next one is deleting the last node. Here we are going to see delete the node at the beginning. Okay, so here we will use one condition, that is ptr tends to next is not equal to start. Okay, so with this condition, what we will do, we will do the deletion. So after deleting, so for this we will use the free function to delete. After deleting this, what will happen, this node will be connected to this, and here it contains the address of this second node, and this will be the start node. So for example, if it is 100 means it contains the address 100, and if it is 150 means it contains the address of 150, and this will be the start node. Okay, we will see the algorithm. So this is the algorithm for deleting the first node. Okay, deleting the first node. Okay, so first underflow condition as usual, because for deleting something it should not be empty, list should not be empty, then only we can able to do the delete operation. So what we are doing, we are checking the if it is null. If it is null means condition is true, means it is underflow. If it is not true means it will go to the step 2. So here we have assigned ptr is equal to start. So this is the start node. So this is the ptr. Then next we have to check the condition ptr tends to next is not equal to start. Okay, we have to check the condition ptr tends to next is not equal to start. And if this condition is true means what it will do, it will execute the statement ptr is equal to ptr tends to next. Okay, it will execute the statement ptr is equal to ptr tends to next. So we will check the condition. We are checking ptr tends to next is start. It is not a start, so we have to change the ptr. So this is the ptr now, and we are checking next is the ptr. So it is not a ptr, so we are checking with the next node. So it is not a ptr. Then next we are checking with the next node. It is not a start node. Then we are checking with this. It is a start node. So the condition becomes false. So it will come out of the loop, and ptr tends to next is equal to start tends to next. Okay, ptr tends to next. Okay, so in here, so I'm giving the memory address. So for example, it is 150, it is 155, and consider this as a 200. Okay, so ptr tends to next. So this is a ptr node, and in the next part it should be start tends to next. So this is a start, and what is the next? It is 155. So it contains the address of the 155. The next start tends to next is next tends to previous. So start tends to next previous. So this part is a ptr. So what is the address of ptr? It is 200. Then what we are doing, by using the free function, we are removing this, and next start is equal to ptr tends to next. So this is a ptr node, and what is the next node? This one. So this is the start. Okay, so first we are checking this condition, that is ptr tends to next is not equal to start. If that condition is false means we have to execute these steps. First what we are doing, ptr tends to next is equal to start tends to next. Start tends to next means this node address. So that is 155. So we have written here 155. Then next, what is the next statement? Start tends to next is next tends to previous is ptr. So start tends to next, it's previous. So previous means this part, it is a ptr. So what is the address of ptr? It is 200. Then next, by using the free function, we are removing this. Then start is equal to ptr tends to next. So ptr start is equal to, what is the ptr tends to next? This node is a start node here. Okay, then we will write the code for this. First we have to declare the variable, that is struct node. We are using one pointer variable, that is ptr here. Okay, then we have to assign ptr is equal to start. We have to assign ptr is equal to start. Then we have to check the condition while ptr tends to next is not equal to start. If this condition is true means it will execute the statement ptr is equal to ptr tends to next. If it is false, it will execute ptr tends to next is equal to start tends to next. Then start tends to next tends to previous is equal to ptr. Then by using the free function we are removing the start. Then have to assign the start node, so start is equal to ptr tends to next. So this is the code for deleting the starting node.